Okay, we're back. So we have our P plugged in, 0.974 times V is equal to N. They have given us N, so we'll plug that in, 0.250 times R, which is our ideal gas constant, so we plug in 0.0821 times T, which our T we know is 293 Kelvin. Okay, so now we just want to solve for V. I'm going to go ahead and simplify this, so 0.974 times V is going to be equal to these three multiplied together. When you multiply these three, you're going to get 6,013.85. To get V by itself, we just want to divide both sides of the equation by 0.974. So this number is going to cancel out on the left, and we're going to be left with V is equal to 6,013.85 divided by 0.974, which is equal to 6,174 liters. Okay, let's look at the second practice problem. This one asks for the pressure in atmospheres of 12 grams of neon gas at 32 degrees Celsius that fills 2 liters in a gas tube. Okay, so this time we know we're looking for pressure. Now, they give us this 12 grams. None of our variables are measured in grams up here, but we do have to find the number of moles, and we know how to convert grams into moles using the molar mass. So let's go ahead and do that. We're going to take 12 grams of neon, and if we bring our units down and to the right, grams of neon go on the bottom, and we're trying to convert this into moles, so moles is going to go on the top. Now, I look up my molar mass on the periodic table for neon. That number is 20. 20 grams of neon is equal to 1 mole of neon. So 12 divided by 20 gives us 0.6 moles of neon. Okay, and that's going to be our N. Remember, N is the number of moles. Okay, so the question asks for pressure. We now know what moles are. The question also says the gas is at 32 degrees Celsius. So our temperature, 32 degrees Celsius. We know we need to convert that into Kelvin, so we'll add 273, which gives us 305 Kelvin. The question also says it fills 2 liters of a gas tube. So that's our volume, 2 liters. Okay, so they've given us P, or they haven't given us P, we're solving for P. We figured out what N is, we know T, we know V. So it looks like we have all the variables we need for our equation up here. So let's start plugging these in. P, we don't know. PV, we know V is 2, equals nRT. Okay, we know N, 0.6. We know R, 0.0821. And we know T, 305. Okay, so like I did on the last one, I'm going to simplify this. So we get P times 2 is equal to these three numbers multiplied together, which will give us 15.02. To get P by itself, we'll divide both sides by 2. 2's will cancel, and you get P is equal to 7.5 ATM. Okay, now I'd like to help you out with one problem on your ideal gas law practice worksheet. We're going to make a couple of corrections here. So take this gas law practice worksheet out. Take a look at number 3. Okay, the rest of these are very similar to what we just did. Number 3 is a little bit different though because it asks for the molar mass. Okay, we know that the molar mass is grams divided by moles. So your problem gives you the volume, 72.5 milliliters, which you're going to need to convert that to liters. It gives you the temperature, which you'll want to convert to Kelvin. It gives you the pressure, and it gives you a mass. Okay, this mass of 0.207. Alright, so our volume, we've got 72.5 milliliters, which is going to be equal to 0.0725 liters. We have our temperature equal to 68 degrees Celsius. Add 273 to that. We get 341 Kelvin. And they give us our pressure of 0.980 atmospheres. Okay. Now, we have everything that we need except for the number of moles. So in this problem, we actually need to calculate the number of moles before we do anything else. So let's plug this into our ideal gas equation, which is PV equals nRT. So our P is 0.980 atmospheres times our volume 0.0725 is equal to N, that's what we're solving for, times 0.0821, that's our ideal gas constant, it's always the same number, times T, which is 341. Okay, so this time I'm solving for N. Alright, so what I'm going to do is divide both sides by whatever's being multiplied by N. Okay, so I'm going to go ahead and simplify this first for us. So we get 0.98 times 0.0725. That gives us 0.07105. That's equal to N times 0.0821 times 341. Oops. That's 27.996. So if we get N by itself, we divide both sides by 27.996. Those cancel. So we'll get N equal to 0.07105 divided by 27.996. That's going to give us 0.00254. Okay, so this is the number of moles. The question asks, though, for the molar mass. Okay, so our question gave us a mass of 0.207. Now, all we need to do is take the grams that they gave us and divide it by the moles that we figured out. Okay, so we'll go molar mass is going to be the grams that they gave us, 0.207, 0.207 divided by the moles we just calculated, 0.0254. And we're going to get a molar mass of 81.6 grams per mole. Okay. So this was kind of a tricky problem, which is why I worked it out. And the other ones you should be able to do just like the example problems that we did together. Don't forget to convert all of your units to liters, atmospheres, and Kelvin.